This video will talk about the applications of the Pythagorean theorem and give you some examples of test questions you might see on standardized tests like the Oakes test or a unit test. This first question has to do with finding the distance across a swamp. Now normally you would have to walk a distance of 34 meters plus another 41 meters to keep your feet dry, so to speak, and stay out of the swamp, and that would be a total of about 75 meters. But that's not the shortest distance. The shortest distance from A to B would be the hypotenuse of this right triangle. So to our right of the problem, I redrew the right triangle with the legs being A and B and the hypotenuse C, and I wrote a squared plus b squared equals c squared, which is the Pythagorean theorem. Then we plugged the leg's length in and look for the hypotenuse. So one leg is 34, so we write 34 squared. The next leg is 41, so we write 41 squared, and together they add up to c squared. Now here's where a calculator would come in handy. 34 squared is 1156, and 41 squared is 1681, and together they equal c squared. So coming over here, together that equals 2837, or c squared. So if that's true, then the square root, if I take the square root of both sides to maintain equality, then c is the square root of 2837, and that's an exact amount in meters. But we really want to know how far it is for us to walk, so we need to approximate that. And on our calculators, we find that c is approximately equal to 53.26 meters. So it would be a shorter walking distance to go through the swamp, 53.26 meters, compared to 75 meters if we had to walk around on dry ground. This next question is a good example of a multiple choice test type question that you might find on Oakes or some other standardized test. This problem involves a dog's house that is shaped like a tent. The slanted sides of the tent are 5 feet in length and the base is 6 feet across. And we're looking for the height of the doghouse in feet at its tallest point. So this is a little bit more complicated. If we know the base is 6 feet across, then each half of that base is 3 feet across. By using that, we can find a right triangle where one leg is 3. We don't know the other leg, we'll call it x for now, and the hypotenuse, the slanted side of the tent, is 5 feet long. So we use the Pythagorean theorem to solve this problem, and again we'll write a squared plus b squared equals c squared, but this time we know the hypotenuse is 5, so we're going to put that in place of c, that stands for the hypotenuse, so we have 5 squared over here. We know one of the legs, the short side of 3, so we'll put that where a is, 3 squared. And we don't know b, which in the picture is x, but we'll just leave it b for the Pythagorean theorem. So now we have 3 squared plus b squared equals 5 squared. Simplifying this, 3 squared is 9. We still don't know b, so leave that as b squared. And we know that 5 squared is 25. Now in this case, we need to get b by itself, so we're going to subtract 9 from each side of our equations, and we end up with b squared on the left and 16 on the right. So if b squared is 16, if I take the square root of both sides, then b equals 4. So it looks like our doghouse for Oscar is 4 feet tall, so we would bubble in 4 as our answer on this multiple choice question. So here we have a Pythagorean theorem question, multiple choice like you would find on the Oakes, without any context or application. In this case, we're asked to find x, and please don't just circle x and say, there it is. We mean the value of x, or how long that side of the triangle is. In this case, that's one of the legs of the triangle. So again, if we start out with a squared plus b squared equals c squared. X is our a squared, or it could be the b squared, but we'll call it a this time. And b is 15, and c is 17. So we have x squared plus 15 squared equals 17 squared. Simplifying, we get x squared plus 225, which is 15 squared, equals 289, which is 17 squared. Now if I take away 225 from both sides to maintain equality, x squared ends up being 64, which is nice because 64 is a square number. So the square root of 64 gives me x equals 8, and if this is a multiple choice test, I would fill in choice 8. Next problem gives us an application of two joggers, and it talks about running distances. So before I start that, I'm probably going to want to draw a directional arrow. We've got north and south and east and west, just so I can keep my bearings straight. Next, I want to map out the problem, and remember, when I use the Pythagorean theorem, I want a right triangle. So I pick a point and I show that the joggers run 8 miles north. Might look something like this. So there's 8 miles north. Then they run 5 miles west. West would be this direction, and that's 5 miles. And so it says, to the shortest distance, to the nearest tenth of a mile, they must travel to return to their starting point. So I have to go all the way back to the start here. You notice that makes a right triangle with a leg of 8, a leg of 5, and a hypotenuse of a known number. So now I want to plug that into the Pythagorean theorem. So I start with my trusty old a squared plus b squared equals c squared. And I want to plug in the numbers in the right spots. So one of the legs is 5, so I'd have 5 squared. Another leg of my triangle is 8, so I have 8 squared, and I don't know the hypotenuse, so that's c squared. So 5 squared is 25, 8 squared is 64, and together that equals c squared. So if I add 25 and 64, I get a total of 89. And that equals the square of the hypotenuse. So they take the square root of both sides to maintain equality. C is the square root of 89. But the question asks to the nearest tenth of a mile, which is an approximation. The square root of 89 is the exact distance. So using my calculator, I found that C equaled about 9.433, etc. And so if they want to the nearest tenth, I'm going to look at that 4, and I'm going to decide if that's going to stay a 4 or go up. And because this 3 is less than 5, I'm going to say that to the nearest tenth of a mile, their distance is 9.4 miles. The next problem involves cutting across a rectangular field. One of the dimensions on the field is 30 yards. The other dimension is 40 yards. And Tanya runs diagonally from corner to corner across the field, taking a shortcut. So Tanya's distance, x, is the hypotenuse of a right triangle, where the legs are 30 and 40. So if I went 30 squared plus 40 squared, I should get the hypotenuse, or x squared. In this case, I would c squared, using the Pythagorean theorem. So 30 squared is 900, 40 squared is 1600. Together those equal 2500. And the square root of that, or the distance from corner to corner, is going to be 50. So in this problem, there's a couple of interesting things to notice. One is that if Tanya had to run from corner to corner without cutting through the field, she would have had a larger distance. She would have had to go 30 plus 40, or a total of 70 yards. But by cutting through at a diagonal, she only has to have a distance of 50 yards. So her distance is shorter. The second thing is that 30 and 40 and 50 are multiples of a very common Pythagorean triple, a 3, 4, 5 right triangle. So if you know and are familiar with a right triangle being 3, 4, 5, then any multiple of 3, 4, and 5 is also a right triangle. So when you see that one of the legs is 30 and the other legs is 40, you know that the hypotenuse is going to be 50, another multiple of 3, 4, and 5. So these are just a few examples of using the Pythagorean theorem to solve real-world problems. There's a wealth of practice problems and other examples on the internet, and I strongly encourage you to do your own research and find more practice as you need it or are interested. I did a quick search and found these websites in particular, and you might notice that some of the questions on this video actually came from these websites, but there is just tons and tons of information out there for you. So good luck and have fun.